What's up, everybody? This is a follow-up video to the video over techniques for evaluating limits using algebra. And in this video, we're simply just going to add on some more examples of problems because these problems can be a little bit interesting. They can be kind of difficult, kind of tricky. So the more examples you see, the better you're going to be. So let's start off with, we're going to do a couple of every type just to kind of see all the different types. So remember, I can't stress this enough. The first thing you should always try is direct substitution. So to find this limit, I'm going to plug in 2. I'll do the denominator first because that's pretty easy. 2 minus 2 is 0, which doesn't spell doom. Because remember, if only your denominator is 0, then your answer does not exist. Pretty easy. It's if we get the dreaded double zero. So let's see here. So we have 3 times 2 squared minus 12. 2 squared is 4. 3 times 4 is 12. 12 minus 12 is 0. So we do get that dreaded case. Now, what do? Well, I don't see any fractions, double fractions. I don't see any square roots. So this is the divide and cancel technique. So I'm going to factor the top, which factors to take out a 3, I get x squared minus 4. The bottom actually cannot be factored anymore. Then I'm going to continue to factor the top. That factors into x minus 2 times x plus 2. So the strategy here, the algebraic technique here is simply factoring and canceling. And then I see that the x minus 2 is going to cancel on top and bottom because anything divided by itself is 1. So those two factors are gone. So the only thing that's left is 3 times x plus 2. You could distribute that if you want to, but you don't have to. So listen, all I did was I did some algebra to change how this function looks, but it's technically not different. So now that I did that, I could redo direct substitution. And I get 3 times 2 plus 2 is 4. So 3 times 4 is 12. So there's my answer, 12. Pretty simple there. Not too bad. I want you to notice what I did, though, is once I did my work down here was to simply to change how the function looked. And then I came back up here and I redid the limit. That's an important step that I want to see you doing. All right, so here's another one. Once again, always start with direct substitution. So 1 minus 1 on top, 1 cubed minus 1 squared plus 1 minus 1. So on top, it's clearly a 0. Let's see here. Now, a 0 in the numerator does not spell doom, because if you get a 0 in the numerator and a number in the denominator, well, that's 0. 0 divided by a number is 0. So that's a number. That would be good. But let's see what happens. 1 cubed is 1. 1 minus 1 is 0. Plus 1 is 1. Minus 1 is 0. Yeah, so we do get that dreaded 0 over 0. So once again, I'm going to have to do the factoring technique here. I don't see any square roots. I don't see any double fractions. Those are the only two possibilities. So the top is already factored. The bottom is actually going to require factor by grouping. So from these first two terms, I'm going to factor out an x squared. And I'm left with x minus 1. From these back two terms, I'm going to factor out a 1, which basically just leaves x minus 1. If you don't believe me, just distribute to see that you do get an x cubed minus x squared plus x minus 1. But then I can keep factoring because I noticed that both terms in the denominator have an x minus 1 that I could factor out, leaving behind x squared plus 1. So there's the x squared plus 1. So that's factor by grouping. Hopefully you remember that. And then once again, I see the same factor, x minus 1 on top and bottom. That factor can cancel or reduce to a 1. Anything divided by itself is 1. So I get 1 over x squared plus 1. So I certainly changed how this function looks. Now I'm going to go ahead and redo the limit. And this time, I'm going to try direct substitution, plug 1 in, and I should get my answer. Let's see here. 1 squared is 1. 1 plus 1 is 2. So I get an answer of 1/2. Really simple. So the divide and the factor and cancel technique is a really nice technique. And it works always if you know how to factor. All right, let's do a couple square root problems. So what do you do when you see a square root? So once again, always try the direct substitution. So let's see here. If I try direct substitution, I get 0 plus 1 minus 1, all divided by 0. Well, 0 plus 1 is 1. The square root of 1 is 1. 1 minus 1 is 0 over 0. So yeah, I got some work to do. All right, now here's the technique for square roots. We're going to multiply by the conjugate. So the conjugate is taking your square root, not changing it, just changing the value in between. So instead of a plus 1, it's a minus 1. Notice the inside of the square root does not change. It's the number in between the square root and the non-square root. So that's that plus 1 there. And then, of course, I can't multiply the numerator without also multiplying the denominator by the exact same thing. And doing the multiplication this way, you're essentially multiplying by 1, so you're going to change how it looks, but without actually changing it. So once again, the top is the only hard part. I got to go ahead and factor, or well, not factor, reverse factor, multiply. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. That's nice. And again, remember the whole point of multiplying by the conjugate is that those outside and inside values cancel. On the outside, we get a positive 1 square root of x plus 1. On the inside, we get a negative 1 square root of x plus 1. Those terms are going to cancel, and anytime you multiply conjugates together, that always happens. So I don't even have to write those down. So then I'm going to jump to the last terms. Negative 1 times 1 is negative 1. And then again, don't do anything with that denominator, and you'll see why in a second. Just rewrite it as x times the square root of x plus 1 plus 1. You don't actually want to distribute the x at all. Here's why. First, the 1s are going to cancel. Plus 1 and minus 1 together, that makes a 0. So gone. So I could go ahead and erase it if I want. All right, then what's going to happen is the factors will cancel. The x factor on top of the x factor. X divided by x is always going to be 1, so that factor is gone. So the only thing left is a 1 on top and the square root of x plus 1 in the denominator. So once again, now I'm going to rewrite my limit as x approaches 0 here. And it looks completely different, but it is the same function. But now when I plug 0 in for direct substitution, I get my answer very, very nicely. So 0 plus 1 is 1. The square root of 1 is 1. 1 plus 1 is 2. There's my answer of 1/2. Cool. Awesome. Let's do another square root problem. All right. So once again, always try to plug in 0. Like kids will come up and say, this isn't working. Nothing's canceling. I said, well, did you try the direct substitution? I don't know. Okay. So plug a 0 in the denominator. You get 0. Numerator, we get 7 minus 0 minus the square root of 7. So 7 minus 0 is 0. Square root of 7 minus the square root of 7 is 0. So yeah, we get the double 0 here. All right, so, and by the way, you're like, how come that always works out to be 0 over 0? Well, because that's when it's challenging, right? Those are the problems I need to show you. When you plug in the number and you get an answer, well, then that's great. There's your answer. Like, why would I show you 10 of those when those are the simple ones? All right, so what do I do here? Once again, I'm going to multiply by the conjugate. Remember, the conjugate is just multiplying, just changing the sign in between. So I'm going to multiply by the square root of 7 minus x plus the square root of 7. Do not change the sign inside the square root. And again, if you multiply the top, you got to almost multiply the bottom. All right, now, the top, as hard as I say it's hard, it's actually easy. Here's why. Those terms multiply square root of 7 minus x times square root of 7 minus x is just 7 minus x. And again, multiplying by the conjugate, the outside terms and the inside terms cancel. Look at that. They're exactly the same. Positive square root of 7 times the square root of 7 minus x. Negative square root of 7 times the square root of 7 minus x. They're just going to cancel out, so why even write them down? So the only thing left to do is the square root of 7 times the square root of 7, and that's going to be minus 7. First off, a negative times a positive is a negative, and the square root of 7 times the square root of 7 is just 7. So that's going to be really nice. And then in the denominator, don't do anything. Just leave it as x times the square root of 7 minus x plus the square root of 7. All right, first the 7s cancel, making a 0. Then the factor x over x will cancel. But be very careful. You don't want to lose this negative sign. There is a negative left there. That negative did not cancel on the x. Just the factors x is canceled. And then again, the denominator, I have the square root of 7 minus x plus the square root of 7. So now I'm ready to redo my limit here. As x approaches 0, negative 1 over the square root of 7 minus x plus the square root of 7. Now try direct substitution, and you get negative 1 over, let's see here, 7 minus 0 plus the square root of 7. All right, so let's spend some time on this here. 7 minus 0 is the square root of 7. So I get the square root of 7 plus the square root of 7. Well, that's going to be 2 square root of 7. A square root of 7 plus another square root is 2 square root of 7. And I'm totally fine with square roots and denominators at this point, so I'm going to go and just leave the answer like that. All right, now let's try some of the double fraction problem. So these kind of stand out. Like, it's pretty obvious when you see one of these. Oh, yeah, I'm working with a double fraction here. So once again, you never know. Like, sometimes I'll try to, again, it's not tricking you, just making sure that you're paying attention. Just because you see a double fraction doesn't mean you're going to have a problem. Always try the direct substitution and see what happens. I get 2 plus 2 minus the square root of, or minus, no, gosh, square root, what am I talking about? Minus 1/4, and I get 2 minus 2. So on top, 2 plus 2 is 4, 1/4 minus 1/4 is 0. On the bottom, 2 minus 2 is 0. So yeah, I got some work. Now, once again, what am I going to do here? Well, the idea, the strategy with fractions is to make one beautiful, simple fraction. So the first thing I have to do is get a common denominator on the top and make one fraction. So my common denominator is going to be 4 times x plus 2. This guy needs to be multiplied by 4, no problem, as long as I do it to the top and bottom. 4 times 1 is 4. Minus this back fraction needs the x plus 2, no problem, I'll multiply. But be very careful, there's a minus sign, so that needs to come along with the 1. So negative x is negative x minus 2. Be very, very careful that I get so scared that kids will miss that. So this is really a negative 1. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. Now, instead of dividing by x minus 2, creating a double fraction, I'm going to multiply by the reciprocal 1 over x minus 2. How easy is that? All right, let's clean this up. This is going to be weird, so bear with me. All right, on top, I have a negative x, and 4 minus this 2 makes positive 2. All divided by 4 times x plus 2. And then, again, if you actually multiply by the reciprocal, well, at the top, I don't have to do anything because multiplying by 1 doesn't change you. So I'm just negative x plus 2. But then I'm going to have an x minus 2 in the denominator. Again, all that does, it's just right here, right? You're multiplying, right? When you multiply, you just multiply. All right, now, I don't see anything that cancels. But, yes, there is, right? There's this little trick to this problem. On top, you could factor out a negative x. So, I'm sorry, a negative 1. If you factor out a negative 1, you're left with x minus 2 divided by 4 times x plus 2 times x minus 2. And I'm so sorry, I'm scramming my work in here. But all I did was I factored out a negative 1, and that turned the top into negative 1 times x minus 2. Now, check this out. The factor x minus 2 and the factor x minus 2 are going to cancel. So after they cancel, I have turned this crazy, ugly function into something so much nicer, negative 1 over 4 times x plus 2. So again, it looks very different, but all I did was algebra, and as long as you're doing the algebra correctly, it might look different, but it's not different. Now that I got that factor to cancel, now I could try direct substitution again, and I get negative 1 over 4 times 2 plus 2. And let's see here, 2 plus 2 is 4, 4 times 4 is 16. So there's my answer, negative 1/16. So notice again, notice the strategy I did on every problem. So the first thing I did was I tried the direct substitution, didn't work, got the 0 over 0. Then what I did was I did my dirty work. Dirty work is doing the algebraic technique to turn your function into something simpler. And again, every problem is a little different. We talked about the divide, the factor and cancel technique, the square root technique, and this is the double fraction technique. But once you get that to be cleaned up and slightly different looking, but not different, then we rewrite the limit, do direct substitution again to get our final answer. So hopefully a couple more examples kind of solidified how to do these problems. And hopefully you won't have any problems with them. But just take your time. Make sure you do be careful with the algebra.